Assalamualaikum and welcome back guys to engineering geology. My name is engineer Abid Ali. This is your another lecture in class. I think you are going to like it. Today we are going to talking about the metamorphic rocks and rock cycle. Right now before we start, I am in a nice comfortable situation in my living room where I get to sit here and record geology lectures for you guys. It's pretty fun actually. Congratulations, we are all kind of in this boat together and we are all doing this in a non-traditional way, which is what this online classes is all about. So with that said, let's go ahead and start with the lecture. Alright, in this video we are going to talking about the metamorphic rocks. Now recall rocks are classified according to how they form: igneous form from cooling and solidify magma, sedimentary form from compacted and cemented sediments, and now our metamorphic rocks. These are one that are going to undergo some sort of change, a metamorphism. And what derive they change is exposure to heat, really intense heat or pressure, intense pressure. So metamorphic rocks are rocks that are changed as a result of exposure to intense heat or pressure. So there are two types of metamorphism that occur in nature. The first type is called contact metamorphism and the second one is called regional metamorphism. Let's talk a little bit about the difference between these two. Now imagine you have a surface of the earth here. As you can see, some trees and these colors here. These are layers of rock underground. I'm going to show you how contact metamorphism works. The reason it's called contact because it involves existing rocks coming into contact with really intense heat, which is generally provided by lava or magma. So magma that one day in intrusion of magma forces its way up these layers of rock. All existing rock are going to be burned by the heat of magma. So all along the edge of this magma shown here in orange, you are going to have rock that have been burned by the heat of the magma. That burning causes them to change, metamorphosize into something new. So anything you see the orange, you are going to have some metamorphic rock. This is called primarily by heat. The first type is contact metamorphism, and that is called by contact with heat. Whenever a rock comes into contact with magma or lava, it is burned or metamorphosized by that heat. But let's talk about the second type, regional metamorphism. Now this one is going to be more from pressure. Now let's imagine that I have a plate boundary here, a fault, a crack, and that these two plates are coming together, so it's convergent plate boundary. Well, as you can imagine, in the middle here there's going to be immense pressure. That pressure can cause the rock trap in the middle to become metamorphized. All along this boundary you will find metamorphic rock. Again, this is different from contact in heat. It is not so much about the heat, it's more about the pressure. Let's take a look what we see here. This is a typical progression metamorphism that occurs starting with sedimentary shale. Now just look at the reference table for metamorphic rock. Again, you notice there's quite a variety and a large list of characteristics and information. Let's take it bit by bit. The top sections are Let's take it bit by bit. The top section are referred to as being foliated rocks, and these form primarily from regional metamorphism, which is primarily a result of pressure. So I can give you an example of typical scenario that occur in nature. So we start with this rock which is known as shale. Now you may recall this was actually a sedimentary rock made of very small clay sized particles. Well, shale, which is very common on the earth's surface, might get forced deep underground by the movement of tectonic plates, and under those conditions the shale would be exposed to increased heat and pressure, and it would be morphed into a rock called slate. Notice they look very similar. Now if the slate get pushed deeper underground, it will metamorphose even more and become something known as phyllite. Even more heat and pressure and we will get a sample of schist. and even more and more we will get the rock called gneiss. Gneiss, notice the band and ice, that is very common characteristics. Now if the sample of gneiss is pushed even deeper underground, the heat and pressure will actually cause it to melt, and that will become an intrusive igneous rock. So this is the result of increasing heat and pressure within the earth crust. So those are our regional metamorphism rocks. Notice something they are called, referred to as being foliated, and what that means is that pressure is causing the mineral within the rocks to almost line up with each other. And now we have two types of foliation. We have minerals alignment seen here, which is when minerals line up as a result of pressure, and then severe version of mineral alignment is called bending, seen here. The only rock that displays bending is called gneiss, and that is results really intense pressure, and this is a result of really intense pressure. But we also have these non-foliated metamorphic rock which are caused by pressure like anthracite coal, right? Remember, regional metamorphism is from pressure. We will take a look that in some moment of these, however, caused more by heat, something called contact metamorphism. When the rock comes in contact with really intense heat from lava or magma nearby, then of course some could be a combination of heat and pressure or pressure. Let's take a closer look at the first one, coal. Now if you recall, there was a sedimentary rock known as bituminous coal, which if you take bituminous coal and you had an intense pressure, it will metamorphose into a new rock that looks similar, but that is much more dense. This is called anthracite coal, and it is a metamorphic rock. That same idea can actually happen to other rocks like the sedimentary rocks and stone, which we mentioned earlier. Now if you add intense pressure and heat to that, and if it comes into contact with magma, and it will affected by the heat, and it will metamorphose into a rock known as quartzite. You can see that right here on that chart. Notice it actually says metamorphism of quartz sand. The same thing will be true underground. Notice we have some layer of sedimentary rock here. Maybe one of those is sandstone, and then one day a magma intrusion force its way up. Whether the magma touches the rock, it's going to cause some contact metamorphism. That's where you would find your quartzite or your hornfels, and even a rock like marble or metaconglomerate, all forming from contact metamorphism. So those are our metamorphic rocks, keeping in mind that the key characteristics to look for with metamorphic rock is bending. You will not see bending in any other type of rock than metamorphic rock. Okay, let's take a quick look at the rock cycle. Here's a diagram showing the rock cycle in the earth crust. What it shows, there are different types of rock and how they can change over time. Let's go through a quick example here. This is a chunk of igneous rock known as granite. You can see it's made up of intergrown crystals of potassium feldspar and quartz and biotite. That's what it gives its speckled look. Now, as we mentioned, granite is an igneous rock which is formed from solidification of melted material, magma or lava. Granite happens to form from deep underground from the slow cooling of magma. But the questions we want to look what now is, well, we can happen this to igneous rock over time, and there's a handful of possibilities. The first thing that could happen is our granite that could be lifted by force from beneath the ground, where it is exposed to weathering and erosion and the wind, the rain and the ice. These forces break this rock into small pieces called sediments. So now our granite has been broken into small pieces of granite. Now these latest small sediments can be deposited and buried, and then compacted and cemented together to form a brand new rock is called sedimentary rock, like this piece of sandstone. So simply by weathering and eroding the granite into sediments and then squeezing the sediments back together, you have converted your igneous rock into a sedimentary rocks. But that's not the only thing that can happen to our igneous rock. What if we pushed even deeper underground by the movement of earth tectonic plates, and in so it is exposed to intense heat or pressure, causing it to metamorphism or recrystallize into a metamorphic rock like this piece of gneiss seen here. So with the simple addition of some heat and pressure, we have turned our igneous rock into metamorphic rock. But there is still one more option. What if our igneous rock is exposed to intense heat, causing it to melt and return into liquid state of magma? Well, it can be of course cool and solidify again, giving us another igneous rock. But maybe this time it will cool quickly and give us some time with smaller crystals, or maybe no crystals at all, like this piece of obsidian. So what you can see is that on rock cycle, any rock is able to turn into another rock when exposed to different processes in and on the earth's surface. Remember, we start with these three types of rock that are our classification, and from them we can go anything else. Again, let's look at the igneous rock. Right, igneous rock we form from melting into magma and solidification. But remember, it can melt again, and that process can happen over and over and over again. So I can have an igneous rock that becomes igneous again, maybe a different kind of igneous rock, but any rock can melt into magma and form an igneous rock as seen on the chart, sedimentary metamorphic rocks. They can all be melted and ultimately results in an igneous rock forming. Well, let's look at the sedimentary rock, and I remember these form from sediments that have been deposited and buried and pressure, causing them to compact and cemented together. But of course, any rock can be weathered into sediments, and therefore any metamorphic or igneous rock can become a sedimentary rock. Finally, we have our metamorphic rock. And remember, these form from when rock are exposed to intense heat or pressure. But of course, that process can take place within any type of rock, sedimentary, igneous, or even metamorphic rock. So the key idea behind the rock cycle is that the fact that any rock can become any other kind of rock, and it can even become itself. Change is always taking place. It's generally slow over many millions of years. However, the result can be impressive. Okay guys, that would be all for today's lecture. If you guys have any questions, any queries, feel free to contact me through the email or WhatsApp. Stay home, take care of yourself.